Hello, this video is about solving quadratic equations, and there is a handout to accompany it. So there are three ways of solving quadratic equations, all of which you met at GCSE. They are factorising the formula and completing the square. If in this case we start with the equation 3x squared plus 7x equals 6, then I have taken away the 6 from both sides to get 3x squared plus 7x minus 6 equals 0, and then I have solved the equation in the three different ways, and as you can see, the answer in each case is 2/3 or -3. The methods will be explained in more detail on the accompanying slides to come. So to solve a quadratic equation by factorising, the first thing we want to do is to make sure that the right-hand side equals 0. So in the first case, it already equals 0. The two numbers we want, they need to add up to 3 and multiply to make -28. So they are x plus 7, x minus 4 equals 0. We've already been practicing factorising. The answers are -7 and 4. For the second one, we take away the 11x first to make the right-hand side 0. The factors are 2x minus 1 and x minus 5 equals 0, so x is a half or 5. The third question is an example of difference of two squares. So the brackets are x minus 6 and x plus 6, giving us answers of 6 and -6. And then for the final one, 5x squared, take away the 14x and the 3 to keep the x squared term positive. The factorisation is 5x plus 1, x minus 3, and the answers are -1/5 and 3. Here we have the quadratic formula, and we've been asked to solve two equations, giving all the answers correct to three significant figures. In the first question, 3x squared equals 7x plus 8. So again, if we take away the 7x and the 8, then we get an equation of the form ax squared plus bx plus c equals 0, where a is 3, b is -7, and c is -8. So that means that b is +7. And then we substitute all the other numbers into there. We end up with 7 plus or minus the square root of 145 all over 6. And the two answers, one with a plus, one with a minus, from the formula are -0.840 to three significant figures and 3.17 to three significant figures. For the second question, it's already in the form ax squared plus bx plus c is 0. So a is 7, b is 1, and c is -1. That means that b being 1 means that b is -1. Again, we substitute all the numbers into the formula, and the answers to three significant figures are -0.456 and 0.313. Finally, we have completing the square. The basic process of completing the square is to take your quadratic equation, which has two occurrences of x in the x squared term and the x term, and rewriting it so there's only one occurrence of the letter x. So here x squared plus 12x can be rewritten as x plus 6 squared minus 36. You will have covered completing the square at GCSE, and the next lesson is all about completing the square. There's also a song there to talk you through the methods, which if you don't know it, someone I'm sure will sing it to you in the class. Over on the left, it's got some information that gets repeated in our next lesson as well about minimum values and maximum values and turning points. And now we get to solve some quadratic equations by completing the square, and we've been asked to leave the answers inserts. So in A, x squared minus 12x plus 34 equals 0. If we complete the square, we get x minus 6 squared minus 36, from which x minus 6 squared equals 2. And then if we square root and add 6, we get x equals 6 plus or minus root 2. In part B, the coefficient of x is an odd number, so we're not going to get whole numbers throughout. We get x plus 5 over 2 squared, take away 25 over 4 plus 3. -25 over 4 plus 3 is -13/4, so we add that to both sides. We get x plus 5 over 2 squared equals 13/4, and then we square root and take away the 5 over 2, which gives us -5 over 2 plus or minus root 13 over 2. In part C, the coefficient of x squared is not 1, but if we divide everything by the 2, we do get a coefficient of 1. So x squared plus 2x plus a half is 0. Carry on in the same way, and we get answers of -2 plus root 2, or plus or minus root 2 all over 2. In question 2, we're looking at how to find the minimum point, more examples of which will occur in the next lesson. So in part A, if we complete the square, we get x minus 5 squared minus 3. So that has a minimum value of -3, which occurs when x is 5, because that makes the bracket equal 0. And that's the minimum value that bracket can equal. And in B, similarly, we get x plus 2 squared minus 3. So the minimum value is also negative 3, and that occurs when x is negative 2. And then finally, in question 3, we've been asked to prove that the expression x squared plus 14x plus 54 is never negative. And we've been told to use completing the square to do that. So if we complete the square, we get x plus 7 squared plus 5. And using a similar idea to question 2, that means the minimum value of the expression is 5, and hence it can never be negative. Just to finish off, as an extra activity for you, I've given you 10 quadratic expressions to factorize. They all end in 72 or negative 72. And to be very kind, I've given you all the factor pairs of 72 over on the left. Okay, the answers on the next slides. So please pause the video, have a go at these, and then you can check your answers on the next slides. And here, as promised, are those answers. Thank you for listening.